Thank you so much for joining this lesson. Remember to subscribe to the channel and to also share the link with friends. Thank you so much. I see people are still joining. People are sharing with friends. Remember to comment. Tell us where you are watching us from. Let us know whether you can hear clearly. Thank you for joining. Thank you for joining. Thank you for joining. Invite a friend. Invite a friend. Yeah, I can see you are increasing. That is very encouraging. So we're going to discuss a linear motion, and allow me at this particular point to focus on my screen now. Yeah, thank you so much. Yes, so I can read your live comments. Just continue following. Just continue following. Just continue following. So we can see I have a sample of questions here. And, this is what we are going to handle first. Motion graphs. Sometimes you'll be given a distance covered, plotted against time. Some other times you will have the velocity of a particle or the velocity of a certain vehicle against time, just as we can see in this case. The figure below is a velocity time graph for a car. So there is velocity plotted against time. We can see the graph. The first thing we are told is to find the total distance traveled by the car. A few things you should master is that for a velocity time graph, total distance covered is usually given by area under the graph. Area under the graph. Area under the graph. So when we look at this graph, you can see, of course, the shape is a trapezium. And the shape being a trapezium now, it means the area for this shape is what will give us the total distance covered. The total distance covered. Therefore, area of a trapezium, total distance will be given by area. This is a trapezium. Therefore, we need half, then A plus B multiplied by H. Remember, A and B are the two parallel sides of the trapezium. Then H is the perpendicular distance between the two parallel sides. Therefore, in this case, we can see if we had to substitute now, we start with a half into A is the first side. The first side is from 0 to 24. That will give us 24. Then we add the other parallel length is from 4 all the way to 20. That is giving us a 16. Then we multiply by height between the two. It's going to be 80. Therefore, you discover that by 2 we will have 1, and by 2 40. Therefore, we'll be talking of 40 multiplied by 40, because 24 plus 16 is 40. So this is going to give us a 1600 meters. So this is going to be the total distance covered. The other thing we are told is to calculate the deceleration of the car. Calculate the deceleration of the car. Remember, there is no specific formula. There isn't a formula that leads us to deceleration. What learners should understand is that deceleration is usually the absolute value of a negative acceleration. So the formula that we have is to give us acceleration. We usually say that acceleration equals to final velocity or final speed minus the initial speed, because we want the rate of change of velocity. Final minus initial divided by time. So in case we calculate acceleration and we discover that the acceleration is negative, then now we will say the particle was decelerating. So in this case, we need to go to our graph now and we monitor the movement of this particle. So this car is moving from 0 to a velocity of 8 in 4 seconds. That is an acceleration. Then from the 4th second all the way to the 20th second, the car is moving at a constant velocity of 80 meters per second, after which now it drops, or rather it decelerates now, decreases in velocity from 80 to 0 within 4 seconds, because it is from the 20th to the 24th second. Therefore, the final velocity during the deceleration, this is now the deceleration. So during the deceleration, we'll be able to talk about a final velocity of 0 from 80 within 4, and this is going to be negative 20 meters per second squared. That is the acceleration, which means now the car had a deceleration of 20 meters per second squared. So that is how we handle a velocity time graph. Gradient of the curve is going to give us acceleration. If the gradient is negative, like in this case, then the particle is decelerating. But if the gradient, like the gradient of this side, which will be positive, then the particle is accelerating at that point. We can proceed and look at another question, still about the same. We are given another problem here, number 2. Remember, I am telling you to kindly invite friends. Remember also to subscribe yourself, just to be a subscribed candidate. Don't just follow. Remember to subscribe so that you may be receiving any updates whenever we upload our lessons, whenever we are going live, for you to be conversant with whatever is happening in Shifting Grades. You are requested to subscribe. Number 2, the question says that a train traveling between 2 stations starts from rest and accelerates uniformly for 150 seconds. It then travels at a constant speed for 300 seconds and finally decelerates uniformly for 200 seconds to rest. Given that the distance between the 2 stations is 10,450 meters, sketch the speed time graph. The speed time graph is also what we call the velocity time graph. That is what we are told to plot in this case. Not even to plot, but just to sketch. Therefore, we need a time on the horizontal axis. And we also need the speed now on the vertical axis. We need speed on the vertical axis. Yes. If this is speed in meters per second, then we shall have time on this axis in seconds. Let us look at the sketch now. From rest, the train is accelerating uniformly for the first 150 seconds. Therefore, we're going to talk of a uniform acceleration from rest in the first 150. Therefore, from rest, so from 0, that's what we call rest. That is an acceleration, but this is happening within the first 150, the first 150 seconds. Then now from there, the particle will have a uniform velocity, So uniform velocity for 300 seconds. So for 300 seconds, then after 300 seconds now, the body is going to decelerate uniformly to 0 within 200. Uniformly to 0 within 200. Therefore, now we need to drop this one to 0. Yeah. This is a good sketch. We are talking of this is happening from 0, the first 150, there was acceleration, then a constant velocity for the next 300 seconds, which means we are going to find ourselves at 450 seconds. And finally, within 200 seconds, there is a deceleration. Therefore, this will be 650. So that is a sketch. Remember, this is up to a height which is not known. This is up to a known velocity. So we don't know the velocity which is attained at this point. Calculate the maximum speed in kilometers per hour the train attained. So for us to know the maximum speed in kilometers per hour, we need to say that total distance which has been provided in this question is usually given by area under the graph. Therefore, we will say total distance, which is 10,450, is equal to half multiplied by the sum of the two parallel sides. So from 150, the first height here, the first parallel length, that is from 150 to 450, there is 300. Then we add from 0 all the way to 650. Then we multiply by a known height, the height between the two. This one. That is the vertical height between the two parallel lines. That will give us that will be able to give us the total distance. So now with this, we can talk about the h, which means we will need to multiply by 2 through, and this will give us 2,900 equals to 950 multiplied by h. And to remain with h, we need to divide through 2,900. So 2,900 divided by 950, and this gives me exactly 22. So 22 is the height there, and the height will represent now the speed, which is maximum. So the maximum speed is going to be 22 meters per second. We also taught to find the acceleration. Remember that this is the part where the train is accelerating. So acceleration is given by the gradient of that line, or simply we can talk of starting from 0 all the way to 22. Now we have known the height here is 22. From 0 to 22 within 150 seconds. Therefore, we can say acceleration will be given by the final velocity of 22 from 0 within 150 seconds. Therefore, we'll be required now to divide 22 divided by 150, and this gives me 0.1466, so we can have 67 meters per second squared. So that will be the acceleration of the train in the first 150 seconds. Finally, there is a part D here, which talks about the distance the train traveled during the last 100 seconds. So the last 100 seconds means the last 100. Remember, there is the very last second is 650. Therefore, we need the distance traveled in that case now. So in the last 100 seconds, now we will be talking about the area of this, and because what we are calling deceleration is uniform, we need to first of all determine the uniform deceleration. Uniform deceleration is going to be of when we take final minus 22 out of 200 out of 200. This is going to give us a 22 over 200, 0.11. So negative 0.11 is what we are calling the deceleration during the last part of the journey. Therefore, with the deceleration now, if we use any constants or any points along this, we are still going to get the same acceleration. Therefore, at this point, we are talking of because we are talking of 100 here, this will be 550. So at 550, we don't know the y coordinate, which will be our velocity. We don't know the y coordinate here, but at least we know when we use it together with 650 and should be 0 and 650. Yeah, 650 and 0. We are also going to get negative 0.11. This will be given by change in y. So the unknown y minus the unknown y minus 0 divided by 550 minus 650. So this is going to be, we have y being equal to negative 0.11, and y is being divided by negative 100. Therefore, for us to remain with y, we have to multiply through by 100, and that will give us exactly 11. Therefore, now we can say, because now the velocity at this point is 11, it means the height here is 11. So with a height of 11 and the length here is 100, we can get the distance within that part now. So the distance will be the area at that point, and we need area to be given by half, because now the shape there is triangle, times a base of 100 times 11. And this will be, when you divide, you get 50. So 550 meters. That is the distance covered in the last 100. The last 100. we are talking of number 3. The diagram below shows the speed time graph for a bus traveling between 2 stations. The bus starts from rest and accelerates uniformly for 75 seconds. So when we go to the graph now, we should know that this uniform acceleration is happening within the first 75 seconds. It then travels at constant speed for 150. So for 150, so when we add 150, we'll find ourselves at 225. And finally, we are told that it decelerates uniformly for 100. So we'll have 325. This is the time in seconds on these axes. Then we have speed in meters per second. Then we are told that given that the distance between the 2 stations is 5225 meters, calculate part 1, the maximum speed in kilometers per hour attained by the bus. So when we're talking about a maximum speed now, we approach it like the number 2 up there. So we'll be talking about a total distance being given by area under the graph. The area is trapezoidal. Therefore, with a trapezium, we need the first, the sum of the parallel sides. So from 75 to 225, we have said that is 150 seconds. So we'll have 150. Then the other one now is from 0 to 325. The lower length now from this point all the way to the end here. Then we multiply by a known height, which will be the speed attained. So now we are going to have we can multiply by 2 both sides to cancel these half. So 5225 by 2. That will be 10 450 equals to, when we take 150 and we add 325, we are going to get 475 h. So the capital H, which is the maximum speed, will be given by 10 450 divided by 475, and this gives us exactly 22 meters per second. Now we want to convert all this. We want to convert this to kilometers per hour. We are having 22 meters divided by 1 second. That is what it means per second. Therefore, to convert 22 meters to kilometers, we have to divide by 1,000. Yeah, we have to divide by 1,000 to convert to kilometers. And for us to change 1 second into hours, we have to divide it by 3,600 seconds. So to divide further by 3,600 means to multiply both the denominator and the numerator by 3,600. So we can convert this by multiplying 22 times 3,600, then we divide by 1,000, and this gives 79.2 kilometers per hour. Acceleration of the bus. For us to know acceleration now, we need to work with this part from 0 to a maximum of 22 within 75. So we will talk of acceleration being given by final 22 minus initial over the time taken. That is the rate of change of velocity. Therefore, we need 22 out of 75, and this gives us 0.2933 meters per second squared. Therefore, that is the acceleration. Number 4 now, on relative speed. We're going to handle 2 questions on relative speed, and then we'll be concluding the lesson. very soon. We'll be concluding the lesson very soon. Thank you for following. I can see people are still tuned. You can invite a friend to this broadcast. Just invite a friend. Yeah. Following live, good work. I'm in. Happy. Hope I'm not late. Welcome so much, Madam Jennifer Zempi. You are not, I don't know, you mean I'm not what? Following from Nairobi. Good work, sir. That is Mr. Kiteto. I appreciate. Thank you so much. All right. Let us look at relative speed itself now. Relative speed, whereby we are talking of a van left Nairobi at 8:30 a.m. and traveled towards Mombasa at an average speed of 80 kilometers per hour. Then at 8:30 a.m., a car left Nairobi and traveled along the same road at an average speed of 120 kilometers per hour. Part 1, calculate the distance covered by the car to catch up with the van. Therefore, a van is leaving Nairobi at 8:30. This is supposed to be at 8. Sorry for this confusion. At 8 a.m., a van is leaving Nairobi towards Mombasa at an average speed of 80. Then at 8:30, that is now half an hour later, a car also left Nairobi and traveled along the same road at an average speed of 180. So now with this, we can first of all calculate the distance which was covered by the van before the car started traveling. So that distance is going to be given by, for half an hour, between 8 a.m. and 8:30, there is a half an hour times a speed of 80. So we are talking of 40 kilometers. So the van is already 40 kilometers away the time a car is starting its journey. Then now the car is starting at a speed which is very high. That is 120 kilometers per hour. That means there is a speed with which the car is approaching the van. That means if the van is moving at 80 kilometers per hour, then there is a car now approaching it at 120. It means there is an approaching speed, which will be the difference between the two speeds. When vehicles or whatever particles are in motion are going to the same direction, their relative speed is usually the difference. So we are saying that a relative speed is going to be the difference between the two because they are going to the same direction. 120 minus 80 giving us 40 kilometers per hour. So if the van is moving at 80 but the car is coming at a speed of 120, then it means there is an extra 40 kilometers per hour, the speed at which the car is approaching the van. So now there is a relative distance, that is distance between the two vehicles of 40 and a relative speed of 40 kilometers per hour. Relative time is usually the time taken to cover the relative distance. So relative time is going to be relative distance out of relative speed. A relative distance of 40, relative speed of also 40. This gives us exactly 1 hour. Exactly 1 hour. Then now we will talk about after that, we are supposed to calculate the distance covered by the car to catch up. So the car will travel for an hour to catch up with the van. This is to mean if it is traveling at a speed of 120, the distance covered by the car to catch up at a speed of 120 times 1 hour, because we get distance by multiplying speed and time. then we shall have 120 kilometers as the distance covered for them to catch up. Then there is a part 2 now. Find the time of the day when the car caught up with the van. They are catching up after 1 hour, and the time they started moving together was 8 a.m. Therefore, we need 8:30 a.m. plus 1 hour. This is giving us 9:30 a.m. the same day. So that is the time they are going to catch up. Time of the day when they will catch up. We can look at another question. Again about vehicles which are following one another, going to the same direction. Bumala is a market center, 600 kilometers from Kisumu town. A bus starts from Kisumu for Bumala at 7 a.m. at an average speed of 80 kilometers per hour. Then at 8:30, a car started. From Kisumu to Bumala and moved at an average speed of 120 kilometers per hour. Calculate part 1, the distance the bus covered before the car started moving. This is from 7 a.m. to 8. Between 7 a.m. when the bus started moving to 8:30 a.m. when the car started its journey. Then we will talk about a time difference of 1 hour 30 minutes. 1 hour 30 minutes is 1.5 hours with the bus moving. So the bus distance covered by the bus, distance is usually given by speed times time. So a speed of 80 and time is 1 hour 30 minutes, which means 1.5, rather 3/2. That is 1.5. This is going to give us a 120 kilometers. So by the time the car is starting its journey, then we are saying that the bus has already covered 120 from Kisumu towards Bumala. Then we are also told to calculate the relative speed of the two vehicles. They are approaching one another. Therefore, a speed of 120 minus the other one of 80. This gives us exactly 40 kilometers per hour. So that is the relative speed. There is also the issue of the time the car overtook. So the time the car is going to overtake the bus, first of all, we need to get the time taken, relative time. The time taken to cover relative distance of 120 at a relative speed of 40. This is going to be exactly 3 hours later. This is when they will catch up. But now, the car is taking 3 hours from when it started moving. That was 8:30. So plus 3 hours, we are getting 11:30 a.m. the same day. So this is the time when the car overtook the bus. There is also the issue of the distance covered by the car before overtaking the bus. So the distance the car is going to travel, remember it's traveling at a speed of 120 for 3 hours. Therefore, we're going to have a distance of 360 kilometers before catching up with the bus. There's a number 6 here, which says a bus left Bondo at 8 a.m. and traveled towards Kisumu at an average speed of 80 kilometers per hour. Then 8:30 a.m. a car left Kisumu for Bondo at an average speed of 120 kilometers per hour. Given that the distance between Bondo and Kisumu is 400 kilometers, calculate part 1, the time the car arrived at Bondo. Remember, the car is leaving Kisumu at exactly 8:30 at a speed of 120, and the total distance is 400. Therefore, for us to get time taken, we need the distance 400 divide by the speed of this vehicle, which is a speed of 120. So 400 divided by 120, this gives us 3.33 hours. So 3 hours, a third means 20 minutes, because a full hour is 60 minutes, then a third of an hour will be 20 minutes. So that is the time taken for the car to arrive at Bondo. And remember, it started its journey at 8:30. Sorry. So we'll be talking about 3 hours 20 minutes from 8:30. This is going to give us 11:50 a.m. the same day. 11:50 a.m. the same day. We're also talking about the time the two vehicles met. So the time they are going to meet means we have first of all to know their relative speed. When vehicles are approaching one another, relative speed is given by sum. You get a speed of 120 and the other speed is 80. So 80 and 120 gives us exactly 200 kilometers per hour. So the relative distance, any distance between the two vehicles, because they are approaching one another, is going to be covered at a speed of 200 kilometers per hour. If that is the relative speed, then we can look at relative distance. By the time they started moving together, what was the distance between them? Remember, from 8 a.m. to 8:30, the bus had covered some distance from Bondo, and that is a distance covered by bus before the car started. Half an hour at a speed of 80. This gives us 40 kilometers. Yeah, a distance of 40 kilometers. Now with that distance, by 8:30, the distance between them is going to be a total distance of 400, and now the bus has narrowed 40. If this is Bondo and this is the other city is what? We have Bondo and Kisumu. We are talking a total of 400. Therefore, if one vehicle has narrowed 40, then it means by 8:30, when the car is starting, the bus is at some point. So the car is starting here. The bus and the car are having a distance of 360 kilometers between them. So that is the relative distance now. 360 kilometers. We said the relative speed is 200 kilometers per hour. Therefore, relative time, the time taken to cover the relative distance so that the two might meet, is going to be relative distance 360 out of 200. And this is going to be 360 out of 200, 1.8 hours. So 1 hour, then what we are calling 0.8 is going to be 48 minutes. 1 hour, 48 minutes. Therefore, they are meeting after 1 hour and 48 minutes. So when they met was from 8:30. They are meeting 1 hour, 48 minutes later. 48 plus 30 is going to be 78. So means 18 minutes, and we carry 1 hour. And that will make this one 10:18 a.m. So by 10:18 a.m. is when the two vehicles will be meeting. Then we are also talking about the distance from Bondo to the meeting point. So distance from Bondo to the meeting point, we can consider the vehicle which is moving from Bondo, which is the bus. So we consider the bus moving at a speed of 80, and for them to meet, they are going to meet after 1.8 hours. Therefore, we will need 1.8 multiplied by 80, and this is 144. So 144 kilometers is the distance covered by the bus for them to meet. But remember, from Bondo, the bus had already covered a 40 earlier. So this would be 184 kilometers from Bondo to the meeting point. That is after considering the bus. What if we consider the car, which is moving from the other side? It will be meeting after 1.8 hours at a speed of 120. So this is going to be at a speed of 120. We multiply by 1.8, and this gives us 216 kilometers. Therefore, the car will cover 216 for it to meet the bus. But now we are asked from Bondo. Therefore, we need to take 400 and we subtract 216. And this will also give us 184 kilometers from Bondo. So the 216 is the distance from where the car is coming from, and that is Kisumu. But now from Bondo, we have to subtract from the total distance. Remember to continue subscribing. Remember to continue sharing this link with friends. Invite more people so that we continue learning. Again, we are to find the distance of the bus from Kisumu when the car arrived in Bondo. We said, okay, we don't know the time the car is going to arrive in Bondo, or maybe it has been already worked out. Yes. So by 11:50, this is when the car arrived in Bondo. We want to know how far the bus is from Kisumu, because the bus is headed to Kisumu, the car is headed to Bondo, and the car has already arrived. So how far is the bus from its destination, which is Kisumu? Therefore, we are going to calculate the distance or the time the bus is expected to arrive. A distance of 400 at a speed of 80 for the bus, we are getting 5 hours. This means that from 8, it's supposed to arrive at 13:00 hours. If this is when it is supposed to arrive, then we need to know that this is the arrival time, the expected arrival time of the bus. But now the arrival time of the car is 11:50. Therefore, 13:00 minus 11:50. So at 11:50, when the car is arriving, the bus is remaining with some time to still travel. Therefore, this is going to be 60, so we get 10 hours, 10 minutes. This is 12, so we get 1 hour. So the bus is yet to cover or to travel for 1 hour, 10 minutes. 1 hour, 10 minutes can be converted totally to hours. That will be 1 hour and 10 out of 60. So 1 hour and a sixth. 1 and a sixth hours is the time which the bus is yet to travel. That means we multiply this one by a speed of 80, so that we may know the distance which is yet to be covered. Therefore, when we talk of 1 and a sixth, this means a 7/6 multiplied by 80, and this means 93 and a third kilometers. 93 and a third kilometers. So the bus is still having 93 and a third kilometers to be covered. That is from Bondo. So there are very many questions of the same setting, and we can look at one more, which is a bit challenging, and I request you to be extra careful as we handle this question. Yeah, the last question. A bus left Malaba at 6 a.m. and traveled at an average speed of 80 kilometers per hour towards Nairobi, which is 510 kilometers away. At 6:30 a.m., a saloon car left Nairobi the same day following the same route and traveled at an average speed of 100 kilometers per hour towards Malaba. After 1 hour, the car had a puncture which took 15 minutes to repair before proceeding with the journey. Determine part 1, the distance covered by the bus in 30 minutes. So in 30 minutes, that is half an hour. Therefore, we'll be talking about within half an hour at a speed of 80, there is 40 kilometers. Therefore, by the time the saloon car is leaving Nairobi, then from the other end, the bus has already covered. The bus has already covered. Let me analyze this journey on a diagram. This is at 6:30, and we have the bus already at this point, having covered 40 kilometers already. And this is the time when the car is starting its journey. Then we are told this is the car starting at 6:30. Then we are told that after traveling for 1 hour, the car at a speed of 100, but the bus at 80. That means before the puncture, the bus is going to narrow a distance of 80 because it will travel for a whole hour. Therefore, there will be 80. Sorry, it's going to be exactly 80. So 80 kilometers. Yeah, 80 kilometers. And we are having a car which is moving at 100 for 1 hour. It's also going to cover 100 kilometers. So within 1 hour, the bus is going to cover 80. And within 1 hour, the car is going to cover 100. Then we are told that now the car had a puncture at that time, which took 15 minutes to prepare. This is to mean that within 15 minutes to repair the puncture, the bus is already covering some distance. Therefore, distance covered by the bus during the repairing of the puncture, it is a quarter an hour, that is 15 minutes, at a speed of 80. This will be 20 kilometers. So during the repairing of the puncture, we will have the bus again covering 20 kilometers. So the bus will be somewhere here. This is 20 kilometers more covered. Therefore, now there is a distance between the two. So we will talk of a relative distance now being given by 510, and we subtract a distance of 40, 80, and 20. That will be 140. And from the other side, there is a distance of 100. Therefore, the time the car finished handling the puncture, we will have to take 510 and we subtract 240. This is going to be 270. So there is a distance of 270 between the two. The bus has covered a lot of distance. The car has narrowed only 100. Then now we can say that there is something called relative speed. That was relative distance. So relative speed will be when we add 100 because they are approaching one another, and 80. This will be 180 kilometers per hour. Therefore, we can now get relative time, which will be relative distance of 270 out of 180, the relative speed. Therefore, when we divide this by 180, we are going to get 1.5 hours, which will mean 1 hour, 30 minutes. 1 hour, 30 minutes. So now we can get the exact time. When they met, time of the day when they met. So we are having from 6:30 when they were moving together, we added 1 hour for them to move. Then there was 15 minutes for a puncture, and they are now meeting 1 hour, 30 minutes later. Therefore, we have 30 and 30 giving us an hour, then 15 minutes here. So 15 minutes and we carry 1 hour. 6 plus 1 plus 1 plus 1. This will give us 9. So 9:15 a.m. will be the time of the day when they meet. 9:15 a.m. is the time of the day when the two met. Finally, there is a part C which says the distance from Nairobi to the meeting point, or the distance from Nairobi to the point where the car met with the bus. So remember, the vehicle moving from Nairobi is the car. Therefore, for them to meet, the car has already covered 100. Sorry, the car has already covered 100, and it's going to cover 1.5 hours traveling at a speed of 100. So it had covered 100, and it is covering from Nairobi 150 more. So this will be 250 kilometers from Nairobi to the meeting point. If we consider the bus, we will still get the same distance. And finally we have the time of the day to the nearest minute when the bus got to Nairobi. Remember, the bus is not getting a puncture anywhere. It is covering a distance of 510 at a speed of 80. Therefore, the bus is going to arrive after some hours. 510 out of 80, this is going to be 6 hours. 6 hours 22 minutes. 6 hours 22 minutes. And the bus started its journey. The bus started its journey exactly at 6. Therefore, 6 hours 22 minutes from 6, it's going to be 12:22 in the noon, or rather 22 minutes past noon, or 12:22 p.m. It is 12 exactly, which is called noon. So when some minutes have passed, then we are going to talk about p.m. So that is the lesson. Thank you so much for following. Subscribe and share.